looking at what happens to a gas when it's under different temperatures. So you had this bottle, and over the top it was sealed because there was a bubble. So there was like a soap bubble covering the top, so nothing can get in or out. Then that bottle was put in warm water. And we saw that that soap bubble, instead of being flat against the lid, bubbled up and around. So what does that tell us about what's happening to the air inside? What do we think made the bubble get pushed up instead of staying flat? What was pushing on it? So there's the air was pushing on it from the inside. All right, so if the air was then able to push on it, what does that tell us about how those air molecules are moving? All right, so they're going to have to move pretty fast. They got to move faster than they were because they have to be able to push that bubble up. And then what does that tell us about how spread out they are? Are they close together or are they more spread out? So if they're closer together, they're taking up more space by pushing this bubble up. So would there be gas at the bottom? So there's gas at the bottom moving around. And then you said it also has to be pushing on this bubble right here. Whoop. So do you think they're more spread out or less spread out? If they're going to be at the bottom and at the top? More spread out? All right. And are they going in all directions like this, or are they all going in the same direction? In all directions. All right. So we have our air molecules all spread out. Are we gaining or losing any air? Is any extra air coming into the bottle or going out of it? Or is it the same amount of gas we started with? Same amount, okay. So then I'll draw a few more. So this is a better representation. So we know that in the warm water, the gas is spread out and has to be moving faster. That way it can kind of blow up that bubble here at the top. All right. Then that exact same bottle with the bubble was put in cold water, and we saw the bubble actually sink back down into the bottle. So what is that? What's happening to the gas now? So they're going to be moving slower and closer together. All right, so then that means they have to stop pushing on this bubble surface as much. That way it could sink back in. So I'll draw them. They're going to be closer together. And then they're moving slower, so I'm going to draw smaller arrows. So like that, is that a good representation of what you guys were thinking? All right. So we're going to take these ideas that when a gas is warm, it should be spread out. It's taking up more space. The molecules are moving faster. And we're going to see if we can explain what happened to that balloon. So we had the balloon, and these are the gas molecules. And then the balloon got warmed up by the heating pad. So what did you see happening to the balloon? What happened to the balloon when you were watching it? So it was on the heating pad, and then what? So looks like it's inflating. Was there air going into it? So it looks like it's inflating, but there's no extra helium going in. So what does that tell us? What are the helium atoms inside? What do they have to be doing if it's making the balloon look like it's inflating, but nothing else is getting in there? Oh, 7. All right, so they'd have to be moving really fast. They're going to be hitting the sides of the balloon, making it look like it's inflating, even though there's no extra gas in there. All right, and then after it was on the heating pad, the guy let go. What happened when he let go of holding the balloon down on the heating pad? What did it do? What did that balloon do? Oh, it was able to float. Hmm. So how is that gas then different? Because it wasn't floating in the beginning. It only floated after it heated up. So what does that tell us about the gas inside the balloon versus the gas around the balloon? Why would it be able to float? Okay. So it's moving. Do you think it's moving more than the air around it that wasn't on the heating pad? Oh, okay. So then let's think about some of these questions from lesson 5. We had, you guys already talked about, you told me already your prediction that the spaces between gas molecules when temperature decreases should get smaller, that the gas molecules get closer together when it cools off. And you also told me that when temperature increases, the spaces get bigger, that we have more space between the gas molecules. So, what happens then when we're talking about density or how densely packed they are? When is the air more densely packed together? When it's hot or cold? Cold. All right. And then when is it less densely packed? Hot slash warm. All right. So then we're going to be thinking about this balloon. So we have the balloon and it's all like deflated looking and sad. And it's on the heating pad. And you guys said it starts to look like it's expanding, inflating, and that it starts to float up. We know that this heating pad is hot, hence why it's called a heating pad. And then we had the balloon up here and it's less scrunched up. What's happening to the temperature when the balloon is up here? It's right before it starts to fall back down. So it's getting hotter up here, up at the top. All right, so it's hot, it's heating up when it's down on the heating pad, and then it's rising up. And then what's happening to the temperature? Does it keep getting warmer as it goes up? So, so you guys think it would cool down when it's up at the ceiling? So then where is that energy going? So we have the energy going from the heating pad into the balloon and it's expanding. But now it's cooling off, so that energy has to go somewhere. Where is it going? Going where? What's around the balloon when it's up by the ceiling? Oh, so could the energy, we'll do energy this way. So we have the heating pad sending energy in. And then when it's up by the ceiling, the energy is leaving the balloon and going to the air around it. All right. And so we know when things get cooler, what's happening to the density. So it's getting more dense. So now we have the air molecules in here coming closer together and then goes back to its crinkled up state. So it cools down, gets more dense. And we can see that because it's getting crinkly. So would that make sense that when something heats up, it'll be able to float and then it'll cool off and start to sink? All right. So just to kind of summarize, make sure I got all of the points you guys were saying, we looked at the bottle with a soap bubble, and that bubble was covering it so we know air can't get in or out, and it was in hot water and cold water. And we looked at a helium balloon. It was sealed. We know air can't get in and out, and that it was on a heating pad and then released. And you guys figured out if you increase temperature, then gas molecules move faster and spread out, making the air less dense. And then when you decrease temperature, gas molecules move slower, get closer together, making the air more dense. All right. So let's see if we can tie that into what we figured out about like hail, where this is coming in. So we have the ground. From our previous lessons, you guys said that the sun was an energy source, and that energy is coming down to the ground. Some of it's reflected, and some of it is absorbed, heating up the ground. And we also know from before we need clouds to get hail. So we need something. We have the ground heating up and we have clouds. What's happening to the air that's right above this ground that's heating up? Think about the balloon. So we have it moving fast, spreading apart. And if it's moving fast and spreading apart, then the air can rise just like that balloon. Air rises. So now we have the air rising, and now we're back at the clouds. So now we can kind of start connecting some pieces for like what's going on. So now we know how the sun and the air and energy is moving through. So we have air rising up, and we'll see what's happening next. Our model's looking pretty good. We're filling in some spaces here.